The next step in the process is defining the communication patterns. Now, efficient communication between services is crucial. Since the various services live in separate processes, anytime one service wants to access other service, it requires some kind of communication. And in even medium-sized microservices system, there's going to be a lot of inter-service communication. And because of that, it's important to choose the correct communication pattern. Using the wrong pattern can lead to slow performance, unmaintainable system, and poor error handling. So you have to know what you are doing when selecting the communication pattern. The main patterns usually used in microservices architecture are OnetoOne Sync, OnetoOne Async, and PubSub or event-driven. Let's explore these patterns. So let's begin with OnetoOne Sync. In this pattern, a service calls another service and waits for the response. The calling services process is blocked until a response is returned from the other service, and if the response takes time, the calling service will have to wait that time. This is called a synchronous request, one that the calling side is waiting for the other side to respond. This pattern is used mainly when the first service needs the response from the other service to continue processing. This is usually the case when the first service wants to retrieve some data that is needed for the flow it's executing right now. Let's look at an example for this pattern. So we have two services, the orders service and the inventory service. The orders service would like to finalize the order, but before that, it must make sure the item in the order is actually in stock. So the orders service asks the inventory service, is this item in stock? And naturally, it cannot continue and finalize the order until a response is received, which in this case is yes. So this is a classic example of the OnetoOne Sync communication pattern. Now, as with everything in software development, there are pros and cons for this pattern. Let's begin with the pros. With OnetoOne Sync, we get immediate response. We don't need to wait for an unknown time until someone will trigger the response. Our code triggers it. And so we can expect an almost instant response. In addition, the error handling here is quite simple. If there was an error calling the other service, we will know it immediately, since we, the calling service, will get an error message and it will be able to handle it accordingly. And last, this pattern is extremely easy to implement. No need for a third-party mechanism, thread handling, or any other complication. This pattern can be implemented using a few lines of code, and that's it. Now, what are the cons of this service? Well, the main drawback of this pattern is performance. As we saw in this pattern, the calling service is blocked until a response is received. This can hurt performance quite badly and makes it dependent on the other service's performance, which the team usually doesn't have control on. So using this pattern should be limited only to cases when you absolutely need the response from the other service. So how do we implement this pattern? So say we have two services, the orders service and the payment service, and the orders service needs to call the payment service. So the way to do that is quite simple. The payment service should expose some kind of web API. This API can be REST or GraphQL or gRPC. It's rarely anything else. Then the orders service calls this API and gets the response. These APIs are synchronous APIs and are designed so that a response is returned from them and therefore should be used for these scenarios. Now, an important note, this kind of connection is called direct connection and is usually not the recommended way to implement inter-service communication. And let's see why. Say we have 6 services in our system. Each one uses direct connection to communicate with the other services. Now, take a look at the diagram. It probably reminds you of spiderweb, and this is really the term used to describe such a situation. If you end up with a spiderweb on your system, you have a problem. Imagine what will happen if one of these services, in this example service D, is changed. This change can be anything, but let's assume the URL of the service has changed. What will happen now is that this change will affect all the services communicating with the service, and we've got here a ripple effect that creates shockwaves across the system. And this is something that stands against the loosely coupled nature of the microservices architecture. So direct connection is not something we want to consider in such systems. So what should we do instead? Well, it turns out there are two approaches we can use. The first one is the service discovery approach. In this approach, we have another service in our system, which is used as the yellow pages of our services. When a service wants to access another service, it first goes to the yellow pages service and asks for the URL of the other service. After getting the URL, the service then uses this URL to access the service it needs. Using this approach, the services only need to know the directory's URL, how to access this yellow pages service. They don't need to know any other URL, and so we don't have any strong coupling between services. You shouldn't try to develop your own service directory. There are a lot of tools that do just that. One of the most popular one is Console, which provides discovery services as well as other services such as configuration, monitoring, and more. You should definitely check it out. The second approach is using a gateway. In this approach, when a service wants to access other service, it goes to the gateway instead. Then the gateway itself goes to the required service and performs the call. In this approach also, the services need to know only the gateway's URL and not the URL of the rest of the services. So what is the difference between the two approaches and which one should you use? Well, that depends. Implementing service discovery is easier, but the gateway can provide more services, such as monitoring, authorization and authentication, and more. The current industry trend is to go more to gateways, and it's quickly becoming the more popular choice. But you can also go with service discovery if you feel more comfortable doing that. Okay, so that was the one-to-one sync pattern. And now let's move on to the next one, the one-to-one async. This pattern, which implements asynchronous messaging, is used when a service calls another service and continues working. The service does not wait for response. It uses what is often called a fire and forget pattern. The service sends the call and goes on with its life. It's not waiting for anything, and it doesn't really care what happened with the message it sent. This pattern is used mainly when the first service wants to pass a message to the other service, so the other service can handle it. It's the responsibility of the other service to handle the message and to take care of any errors that might have occurred. The first service simply doesn't care. For example, let's say we have these two services, the order service and the payments service. The order service wants to notify the payment service that an order had been placed and that a payment should be performed. So the order service sends an async message to the payment service and doesn't wait for a response. He doesn't really care what happens next. It's the responsibility of the payment service to make sure everything works and if there is any problem, to handle it. Now, what are the pros and cons of this approach? Let's see. The biggest advantage of the one-to-one async pattern is in its performance. When the calling service shouldn't wait for a response, nothing blocks it, and the performance doesn't take a hit when the other service takes its time handling the message. So this is the main reason for going with async messaging. And what are the drawbacks? Well, there are two. First, the setup is more complicated. As we will see in a minute, async messaging is usually done using a third-party tool, requiring setup and maintenance. In addition, the error handling here is more complicated. It's more difficult to trace the error, where exactly did it happen, and what were the reasons for it. Now, how do we implement the one-to-one async pattern? So here are our two services, the orders and the payments. But in addition to these two, we have another tool, a queue in between. You can use whatever queue engine you want, but one of the most popular is RabbitMQ, which succeeds mainly because of its easy setup, simplicity, performance, and the fact that it's free. So take a look at it. So the order service sends a message to the queue, which then relays it to the payment service. What's important to note here is that the order service completed the flow when the message was received by the queue. It has no idea what's happening next and when or whether the message reached its destination. This is the responsibility of the queue, and this what makes this pattern really asynchronous. So that was the one-to-one async pattern, and now let's move on to the next and last pattern. And this pattern is the PubSub or event-driven pattern. In this pattern, a service wants to notify other services about something, and note the use of the plural services, not only a single service, but multiple services. Now, the service has no idea how many services listen to this notification and how many will actually get it. And this is the main difference between the one-to-one async pattern and the PubSub pattern. With one-to-one async, the service usually directs the message to a specific service, even if it has no direct contact with it. With the PubSub or publish-subscribe, the service publishes a message, and other services who subscribe to this kind of message will receive it. The service doesn't know how many services are subscribed to the message it publishes, and it doesn't really care. In this pattern, similar to the one-to-one async, the sender doesn't wait for a response, and it implements a fire and forget pattern. This pattern is used mainly when the first service wants to notify about an important event in the system and to let the other services decide whether they want to do something with this event or not. Because this pattern is often related to events, it's sometimes called event-driven. So let's see an example of this pattern. Say we have the orders service. An order has just been cancelled, and the service thinks this is an important event other services should know about. The service then sends a PubSub message notifying about the cancellation, and the other services that are subscribed to this event handle it. In this case, all the services are interested in this event. The inventory service should return the order items back to stock. The customer service should reduce this order from the number of orders for the customer, and the payment service should issue a refund. So this is a classic example of a correct use of the PubSub pattern. Now, what are the pros and cons of this pattern? So in the pros, we have performance, which as we saw in the one-to-one async is greatly improved. And as we saw, this pattern also allows us to notify multiple services at once, which is not possible in the other patterns we saw. And what are the drawbacks? So first, as with the async pattern, this pattern requires complicated setup and uses third-party tools. In addition, it's difficult to handle errors in this pattern. There are a lot of moving parts, and pinpointing the exact location and cause of the error is not easy. And last, this pattern might cause load on the system. If we have a lot of messages and a lot of services subscribed to them, this might incur high network traffic and a lot of CPU and RAM usage that might make our system slow. So, how do we implement PubSub? So say we have three services: orders, payments, and customers. Now, similar to the async pattern, we also have here a middleman, an engine to perform the PubSub. As with async, this engine can be RabbitMQ or other engines such as Azure Event Grid. The order service sends a message to the PubSub engine, which in turn publishes the message to all the subscribed services. This way, the sender, the order service in our case, has no idea how many services actually got the message, and it doesn't really care, which is the whole point of the PubSub pattern. Okay, so we've covered a lot. Let's summarize the communication patterns we saw. So, as we said, choosing the correct communication pattern is crucial. It affects the performance, the error handling, and the flow of the communication. And remember, it's almost impossible to reverse. So make sure to choose the right communication pattern from the beginning as part of the components mapping step. Great, so that was the communication pattern step. And now let's move on to the next one.